Hi, hello. Welcome to chapter 8 again. Previous one is the introduction or review of all the chapters of chapter 8. So I'm going to discuss part 1 here in this chapter, and just before that, I'm going to briefly go over what topics I'm going to discuss. So these are the list of topics that I'm going to discuss, and I'm pretty highly involved in first 4 topics. And the last one is I'll just go over those trends. um, just not I will go over it lightly. So first 4 topics is what really important to you. What I'm going to do in the first topic is I'm going to introduce you chemical equations. Mostly I'm going to teach you how to balance a chemical reaction, and I'm going to introduce you a few common types of chemical reactions there. Okay. And that is manageable, although balancing chemical reactions for some can be challenging. I have a plan for it. I developed a new style of explaining just for this, class. I worked several hours on it, tried to how to make it better. And then I'm going to go over combustion analysis. And there is a topic, something familiar to you, empirical formula. We briefly discussed empirical formula before in chapter 6 when we discussed Lewis structures, the lowest ratio of elements in a molecule. Here we are going to discuss empirical formula in a sense of moles and how to identify it experimentally. That's really cool technique. And in topic 8 and 3, they were related. That is when we are going to do the chemical we are going to do the mathematical calculations based on chemical reactions. And when people say, chemistry is hard, this is when it actually gets really hard from here. Not for all of us, but not for all the students, but it does poses some challenges to some students, but almost all of my students will eventually get it and do really good in these topics. So what we do in 8.3 is we are going to discuss how reactants and products are related to each other and how to identify how much of products you're going to form. And in 8.4, we are going to discuss the type of availability of the reactants and how it is related to the productivity of a chemical reaction. Again, in 8.5, I'm just going to go over the trends. So 8.3, 8.4 can be challenging, at least for half the class always. And you guys need my help, a lot of help, even after these lectures. Well, hopefully I'm going to, mesmerize you guys and get the best out of me, and you guys will knock it out of the park the first time I hear. Ideal case, but if not, I'm still here. I'm going to still help you in person as well. Let's just go over this and see what we can do, right? So I'm just going to go over the first topic here. Let me make sure I am sharing my screen. Am I? Yes, hopefully. Think so. Sharing my screen. Yes. Yeah, I don't want to record all these videos by not sharing my screen. That would be horrible. All right. So 8.1. So here is where we are going to start discussing about chemical equations. But what is a chemical equation, right? So a chemical equation uses chemical symbols, or in other words, molecules, to denote what occurs in a chemical reaction. So in simple words, a chemical reaction has the list of molecules that are going to react with each other and list of molecules that were produced because the reactants reacted with each other. So that's what a chemical reaction is. And this is how we normally write chemical reactions. There is a style that we write chemical reaction, that is, you write the molecule that you think you're going to react with each other. It's like, you put them in the same pot. That's what reaction means. You put them in the same pot in maybe a water or maybe an organic solvent. but you put them in the same spot, same pot, and you wait for them to react with each other because they were molecules, right? You cannot physically make them react with each other. You just have to mix them and provide the conditions that they would like so that they would react with each other. So the ones on the left side are the ones they were reacting with each other, and we use the arrow to symbolize that reaction is happening between those molecules. Reaction is happening between these molecules and it is forming the product. So after the arrow, the molecules are called products, and before the arrow, molecules are called reactants. Yes, I'm giving you too much information already. So this is I already have nicely. So each chemical reaction has, molecules before the arrow and after the arrow. The molecules before the arrow are called the reactants. Now NH3 and HCl are called reactants. And the molecules after the arrow are called products. So NH4Cl is a product. So from now on, when I say reactants, you need to have the clear understanding that I am referring to the molecules before arrow started. And when I say product, you need to have clear understanding that I'm referring to the molecules, a molecule or all the molecules after the reaction arrow. Reactants on left side and products on right side. This is the terminology that we use in chemistry. And in addition to the reactants and products, we just want to be as specific as possible. We want to give as much information as possible. When you say chemical reaction, you're trying to say that these two reactants are reacting, and it is always useful to tell what is the physical state of those reactants so that the reader will have easy time in understanding what type of reaction you're talking about. Are you talking about reaction between two solids that you're fusing them, or are you talking about reaction between two liquids, or a solid and liquid, or a solid and aqueous solution, or an aqueous solution and a gas? What are you talking about, right? So you need to include the physical states of the molecules, the reactants and products to make it a complete reaction. So these are the different types of physical states that we were exposed to in chemistry. We used these small symbols to denote these physical states. So gas represented as Z, and liquid represented as L, and solids represented as S, and aqueous solutions, what it means is a solid dissolved in water. We do that to make the reaction feasible because solids will have hard time reacting with another solids because they have less of a surface area. But if you dissolve it in water, let them separate as in the ions, then they can react pretty well. So you come across these aqueous solutions a lot in next two terms. So NH3 is a gas and HCl is a gas. And when those two react, they form NH4Cl is solid. Unless I told you that NH3 and HCl are gases, you would not have an image of what is the chemical reaction actually physically would look like. Because they both are gases. Now you wouldn't expect those NH3 and HCl to react on a open flask on a bench top, right? Because they both are gases, they have to be in a closed container. That is only when there is no other gas, these two would react without diffusing. That's why we need to include those physical states. And here SO3 gas is reacting with water, the pure liquid, to form H2SO4 aqueous solution. So what aqueous solution means here is H2SO4, the acid molecule, dissolved in lots of water. That's what it means. All right, so I bumped this topic earlier so that you would know what I'm talking about when I balance the chemical equations. I changed a little bit the order because I feel like you need to get the exposure to the types of chemical reactions before you learn about how to balance the chemical reactions. Okay, so there are three broad categories of chemical reactions that we discuss in chemistry. and they were called as a combination or decomposition or combustion. First two chemical reactions are self-explanatory. The name itself will explain what you're going to expect. Combination basically means two or more, or two, most likely two, most common ones, two or more reactants would combine to form only one product. That's what a combination reaction is. And here is an example. You have two reactants combining with each other to form just one product, NH4Cl. And name self-explanatory, right? You're talking about combination reactions, and they both are combining to form one product. So decomposition is also self-explanatory. So in a decomposition reaction, you have a reactant decompose to form two or more products. So here, calcium carbonate under heat, that's the symbol for heat, decomposing to form calcium oxide and carbon dioxide. And last one is not self-explanatory, but I can explain. So combustion reaction. So a combustion reaction is a traditional hydrocarbon reactions when they were burned under the presence of oxygen. I almost said water. I don't know why. So let me say it again. Hydrocarbons are, what are the examples of hydrocarbons? Are gasoline. The gasoline that we use is a hydrocarbon. It just contains carbons and hydrogens. Or the natural gas that we use at homes in the furnaces, like propane or butanes. So those are also hydrocarbons. So the hydrocarbon is under the enough temperature, in the presence of oxygen, they burn to produce the byproducts, specifically carbon dioxide and H2O. And these are the only byproducts that are formed when the hydrocarbons reacting with oxygen. So that's why we give it a specific name called combustion chemical reaction. And in some cases, in very few cases, the hydrocarbon may also have oxygen. They were not that popular, but still they can still form the carbon dioxide and water, and we can still call them as combustion chemical reactions. Now I'm going to teach you a little bit, because I just teach you what are different types of chemical reactions are. So here what I have is different set of chemical reactions, and I expect you to identify them as either a combustion reaction or a combination or a decomposition reaction based on the characteristics that we discussed in the previous slide. So here, if you look, this is how you would analyze. It's not really complicated yet, right? So you look at the chemical reactions, you look for the reactants, and if you have one reactant or more reactants, and you look for the product, if you form only one product or more than one product, or if those products are CO2 or H2O, because you're only trying to look for three different types of chemical reactions. Is it a combination? Is it a decomposition? Or is it a combustion? And we do have at least two more reactions that we don't discuss right here in this chapter, but I don't want to mess up that. After this, maybe I will discuss those two. So this is how you would identify. So first reaction has two different reactions, but only one product. That's what you need to extract out of that chemical reaction to be able to answer the question it is asking. So second question has one reactant reacting with oxygen but producing CO2 and H2O. Looks like something of trademark to me. And the third reaction, C, has one reactant but forming two products. So do you have your answers ready? I hope you all got it right. So your first reaction is a combination reaction because only one product is formed. And your second reaction is a combustion reaction because you have a hydrocarbon in with oxygen. It formed CO2 and H2O. So forming CO2 and H2O is a trademark to identify a chemical reaction as a combustion reaction. And the third reaction is one reactant separated into multiple products, which is a trademark for decomposition. Okay. So I'm not Excuse me. So I'm just going to briefly talk about the two other types of chemical reactions that were not discussed here, but if I just say it once, you wouldn't be surprised when you hear those names from me in future. So those are the two excluded reactions that are not discussed here are called single replacement and a double replacement reactions. And maybe when the time comes when I feel like it is necessary for you to get the exposure to those chemical reactions as well, maybe I will ask. But just know that there are two different types of chemical reactions out there, right? So let me go to the next topic that we are going to spend quite a bit of time on this topic that is called balancing chemical equations. Okay, so whenever you have a chemical reaction, the chemical reactions must be balanced. What does it mean must be balanced is you need to have same number of atoms on the reactant side and on the product side. Let me say that again. You need to have same number of atoms on the reactant side as well on the product side. Why is it because? It is because that's what law of conservation of mass says. As we discussed in chapter 2, we discussed that according to law of conservation of mass theory, as I stated here, the mass is always constant, right? Irrespective of the changes in the form, like changing physical state also, but mass is always constant. The principal matter neither can be destroyed nor created. It can only changes the form, but you cannot create or destroy it. So because of that, total number of atoms you started with must match total number of atoms you end with in a chemical reaction. So for that reason, you need to balance the chemical reactions. You need to make sure that they were all used up, all the atoms to produce the products, and you can see all of them on the both sides. So we are going to spend some time on this topic. So balancing that chemical reactions is achieved through writing the stoichiometric coefficients. What does stoichiometric coefficients means is ratios, balanced ratios of coefficients between reactants and products. So these are the coefficients that you are looking at. Do you see the 2 in front of H2? Specifically, let me write it or point it. That 2 is the coefficient there. And water has another coefficient too. We are not talking about substrates of a molecule. They were irrelevant when you balance the chemical reaction. Only the coefficients will tell how many times of that molecule or atom is present. So when there is no number present, you should assume that there is 1. So coefficient for O2 is 1. So what we are going to do in next 10-15 minutes or longer is how do you come up with those numbers of 2, 1, 2 by yourself if I do not give you any of those coefficients? You need to come up with those correct ratio of coefficients so that you will have total number of atoms on both the reactant side and the product side, because that's what law of conservation of mass is, that matter has to be the same before and after, because we cannot create or destroy the matter. All right. So balancing chemical reactions requires a trial and error approach. In other informal words, it is a bit messy work, or at least until you get used to it, or maybe even after you get used to it, it is a little bit messy work. That's what nicely is saying it is a trial and error approach. So obviously, if you're trying to do something, you need to have rules, right? So here are the common rules that we are going to discuss by textbook. And also I'm going to show how to use these in the real examples. I'm going to work on the slides to show you how I would approach it so that you would know what is the best approach to do it. So rules are important, especially in chemistry. Rules are important. So the first rule is change the coefficients of compounds before changing the coefficients of elements. You need to know what it is meaning. It is asking you to change the coefficients of the compounds first before you change the coefficients of the elements. So let's see what molecules we have. H2 is a molecule, and O2 and H2s are happen to be the elements. Those are the few examples of diatomic elements. Yes, hydrogen is in a single atom, but it exists in elemental form as H2 and O2s because of their special reasons of being stable. So you need to start trying to start balancing the coefficients of compounds first before the elements. That's huge first rule. And I'm just going to add a little bit further. You're going to come across molecules, are all of your reactants and products are compounds. And how do you choose which one to start with is start with the more complex molecule first. That will make your life a lot more easier. Okay. Please note this down because this is where you get trapped, feel like you are not moving anywhere. And often students come to this illusion that there must be something wrong with the question. That's a little bit funny. It always happens every year. This is one reason why it will happen to students. I'm sorry, I'm laughing at you guys, or future yourself. I'm laughing at you in a funny way, not serious. I'm going to help you. So please write this down. So if you happen to have all of your reactants and products are compounds, how do you choose which one to start with? Is always trying to balance the atoms in a more complex compound. That's where you need to start. Then everything will fall in place like a dominoes and you will solve the problem in no time. And secondly, this is very important, in some molecule have groups. We discussed that in chapter 5 where you try to name molecules like phosphate, sulfates, and nitrates. Sometimes they come as a group rather than individual elements. So treat them as groups rather than just single atoms. It will not make your life miserable if you do that. I'm going to remind you how to find them. And polyatomic ions, we are not cheating in chemistry. Polyatomic ions are kept in a parenthesis. Let's see. Maybe that's one example, not clearly, but maybe that's one example like that. It is put in a group. So just treat them as groups. That will make your life easier. And lastly, it is just cross-checking. You not just, I shouldn't say that. That's very important. You should cross-check your work back because things change in the middle when you balance a chemical reaction. So what the explanation I have, I'm going to work on, I believe, 3 problems. I'm going to work on in a different approach rather than textbook. So I erased whatever the textbook include in these PowerPoint slides because I want to show you how I think it's best to approach this. And I'm trying to aim for a student who would have a little bit difficulty or a lot of difficulty when trying to solve balanced equations because I would come across lots of students each year. So if you're a smart guy who easily get it, don't get irritated with it. I need to teach for everyone in the class. So let me give my shot at explaining to you how do you balance a chemical reaction, right? So it is the chemical reaction and it is asking you to balance because currently there are no coefficients in front of any reactant or any product, which is a good indication most of the times or at least few times that it is not balanced. Let's see if it is balanced or not. Let me first check carbons. There are 3 carbons here, only 1 carbon here. So clearly this reaction is not balanced. And the question is asking us to balance this chemical reaction, which is what I will ask you to do a lot of times in this class or in the quiz or in the test. So this is how we start. You need to start balancing compounds first rather than individual elements. And if you have more than one compound, and I suggest you always start with a more complex one, and in most cases that is contains more complex molecule in the sense that it contains more atoms. So let's, and also in a way that it present in a less number of products. I know I'm throwing a lot at you without showing what I got. I'm not trying to hide my cards, I'm just trying to prepare you guys. So this is what the plan I have. I'm going to work here, and this is what I want you to do. I want you to write down all the different elements that you see, both on products and reactant sides. Okay. Maybe I need to move the hydrogen a little bit higher there. Let me do that. Hydrogen. So this left side is for reactants and right side is for products. Clear so far? Okay. So what I want you to do initially is just identify how many types of each one of these atoms are present in a given chemical reaction to you before you balance. And carbons, I see 3 carbons here, so I'm just going to write 3 here, excuse me. And on the reactant side, I want to see 1 carbon, so I'm going to write 1 there. So oxygens, I see 2 oxygens. On the reactant side. On the product side, I see this is what I'm going to do differently. I see total 3 oxygens, but I see them in 2 different compounds, and I still know there are 3 oxygens on the product side, but I want to clearly separate which oxygens comes from where. So there are 2 oxygens from CO2 and 1 oxygen there, but we still eventually going to match both reactant and product side. But I find that it is confusing to mix all of them as a 3 for majority of the class. So I'm just going to differentiate them and work on them. So now hydrogens. There are 8 hydrogens on reactant side. This is where I find, and there is only 1 place where hydrogens are on the product side, so 2 there. So now it is always best to start with, most of the times this is where I start on carbons, and then I go to hydrogens because hydrogens are mostly always connected to carbons. Then I come to other elements, and most of the time it is either oxygen or nitrogen or any other elements. Okay. So on the reactant side, I see there are 3 carbons, but on product side, I only see 1 carbon. So how do I make sure on both sides I have equal number of carbons is I can change the coefficient in front of the product CO2 molecule to make whole number of carbons as 3. So I'm just going to, currently the coefficient in front of CO2 is only 1. So I'm going to cross it and say that there should be actually 3 in front of that carbon. Okay. So when I say that, I can confirm that this is where I'm confirming eventually that there are 3 carbons on both sides. That's matching. I just made sure that on both sides there are 3 carbons. Now, when I do that, I need to make sure I'm paying attention to the any other involuntary changes to the number of atoms that I made. Now, by putting 3 here, right? Excuse me. By saying I want to put 3 in front of that CO2, I made changes to the number of oxygens already because it is a whole molecule. It does not just affect the number of carbons, it also affects the number of oxygens there. So the 2 oxygens in 1 CO2 is now going to change to, if I multiply with the 3, change to 6 plus 1, right? because I put 3 in front of them. So there are a total of 6 oxygens. Okay. Now, I should have put hydrogen on top and oxygen on the bottom, but this is my preference. This is where you get the good luck. So I'm just going to go to hydrogen, even though it is at the bottom. So on the left side, on the reactant side, I have 8 hydrogens, but on the right side, I only have 2 hydrogens. How do you make sure I have 8 hydrogens on both sides? It's a simple math, right? If I multiply or if I change the coefficient in front of water as 4. So for example, if I put 4 there, my whole number is going to change to 8 because 4 times 2 is 8. So I have equal numbers, so I am just showing off. Or I can even check mark. Okay, so which left me with dealing with just oxygens, right? So currently, this is where it gets tricky. There is an odd number, 6 plus 1, 7. Now, when you already balanced a molecule, you do not want to rebalance that. That is how balancing already works. It's like dominoes. You don't want to go back and recorrect the balances that you already balanced. If you're trying to do that, you are going on wrong route. So I already balanced CO2 by putting 3 in front. So I am not changing anything to that CO2. So this 6 is staying good. I'm not changing the number of oxygens from the CO2. So if I'm going to make any changes, I'm only going to make the changes to any other oxygens. Well, actually, I'm going ahead. So by making, well, this is what happens, right? Even I know that I have to go slowly. I still went too fast and missed the step. Once I balance the hydrogens, I need to slow down and ask myself, did I make changes to any one of the atoms involuntarily? Actually, I did, but I did not pay attention in explaining this. So here, by putting 4 in front of water, I actually changed number of oxygens. Now I'm going to multiply that one with 4. So it is going to be 6 plus 4. So I have 10 oxygens. Now my goal here is to have 10 oxygens on the other side. Then my reaction is balanced. So to do that, I need to put coefficient 5. So I will have 10. Or you can say I'm multiplying with 5 to get 10. But bottom line is I got same number of oxygens on both sides. So that is how we balance a chemical reaction. Like I said, it gets a little bit messy, but if you follow these rules of starting with more complex atom, and once you balance one atom and look for involuntary changes happening to the other atoms, then you will be on safe hands. It takes time and patience, and you need to go really slow when you balance a chemical reaction. That is when you get the most accurate result. It is just confirming that we have the same balanced chemical equation. You have 5 in front of O2, 3 in front of CO2, and 4 in front of H2O. This is how you balance a chemical equation, right? I got, believe, 2 more balanced chemical equations that we are going to practice. So another chemical reaction, and it is asking you to write a chemical reaction between barium hydroxide and perchloric acid. Here we are using names because it is a common expectation for you to know those structures, because that's what we did in chapter 5 mostly, right? Trying to identify molecules by name. So barium hydroxide should have a barium with the OH group twice, and HCl4 is perchloric acid is HClO4, and producing barium perchlorate is this molecule and water. Okay, now these two are the reactants and next two are the products. Now we just need to know what are those physical states are. Barium hydroxide is a solid, HCl4 is an aqueous solution, and barium chloride is also aqueous solution. Water is just going to be liquid, right? It's a pure liquid already. Now, our job is to, where we just put them together as reactants and products. Our job is to come up with a balanced chemical reaction to have the same number of atoms on both reactant and product side. Let's do that. So you have the unbalanced reaction on the top, and I'm going to work on how to balance this chemical reaction, just like the previous step. So let's start from here. Before I start, let me highlight you what is a polyatomic anion is. ClO4 is a polyatomic anion. How do you identify? Because it is clearly present in the parentheses. You cannot miss it. If it is present in the parentheses, it is a polyatomic anion, and you can just treat them as polyatomic anion, just one group, by identifying where is that group is present. That just makes your life so much easier. Otherwise, these gets really tricky to solve. It kind of open like a spiral loop that you cannot come out unless you identify those polyatomic ions and separate them before you start balancing the chemical equation. Now, let's start with barium. Barium looks more complex, right? Let's start with barium. And after, I want to start with barium and maybe doesn't matter, hydrogen or oxygen, we can do either way. But I always want to go to hydrogens next, as early as possible. That's kind of basic preference, and it always works. So bariums. Bariums currently is one barium here, one barium here. Well, let me just get the list of all the atoms that are present there. So there are 2 oxygens here that I'm seeing here. Because of the appearances, there are 2. I'm not counting these oxygens next to this because it is just counted as one whole polyatomic anion group. And I find another oxygen here. So that makes it as just 1 oxygen, right? And hydrogens, I find the 2 hydrogens in here, and I find 1 hydrogen in here. 2 plus 1. And on the right side, I only find 1 set of hydrogens in water. I do not find any hydrogen in barium perchlorate. And ClO4, there is 1 here, 2 here, because of the subscript to the bracket. Okay. Now let me just clear it to get your focus where I need you to focus. Again, if you already get what I'm trying to say, you can just go ahead and try to balance yourself and race with me, and probably you would finish sooner than me. So bariums looks like they were already balanced. I'm not going to do anything because it's already 1 and 1. What can you do there if it is already balanced? Let me get my proud check mark. There you go. So then let's see if we can balance the oxygens. So oxygens on one side saying 2 and another side saying 1. Looks like it is classic multiplication. So you will have 2 here. You already have 2 here. Check. Quicker, right? So hydrogens on one side, you have 2 plus 1, and on another side, you only have a 2. How it is possible? Am I going quicker than I should? ClO4. Okay. Well, hydrogens looks complicated because hydrogens are part of this group as well. Let me just go to ClO4s, right? ClO4 on one side you have 2, and on one side you only have 1. It looks like if you just multiply this with the 2, you would get 2 here. You already got 2 in here, so cross check. So now when you do that, why I come to ClO4 here is when you do this ClO4 change 2 in here, you involuntarily change number of hydrogens. Number of hydrogens from 1 it changed to 2. Now it's actually 2 plus 2. This is what I mean. These hydrogens stayed the same, but by putting coefficient 2 in here, I changed this 1 hydrogen to 2 hydrogens. Now we got 4 hydrogens on one side and 2 hydrogens on another side. See if we can balance that. Now, on 2 side, if you multiply that with the 2 instead of, if you put coefficient 2, you will have total 4 hydrogens by putting 2 in here, and you already have 4 hydrogens there. So you balanced it. That is how you would balance. Again, it's a trial and error approach. If you make a mistake, you can come back, but you always need to go slow, look for involuntary mistakes. So if you try to balance this, you should have a 2 in here, and you should have another 2 in here. That's it. Your reaction is balanced. You will have, say, equal number of atoms on both sides. If you want, you can recheck again. This is one of the difficult ones. Let's work on, okay, let's work on one more problem. The butyric acid, which is found in fat milk, and which they extracted from rancid butter in the late 19th century, and which is shown to have some effects on being an anti-cancer agent. So they were asking us, what if that butyric acid is processed under a combustion reaction? What type of products would you form? What is a combustion reaction again? A hydrocarbon or a hydrocarbon with oxygens, when reacted with O2, it would produce CO2 and H2O. So the reaction is asking us to write that combustion reaction and produce the products. So this is what we have. That is your unbalanced equation for butyric acid C4H8O2, and you have O2. You need to have O2 for a combustion reaction as a reactant, and the classic products are CO2 and H2O. Again, I have this preference to go from carbons to hydrogens to oxygen. That is when you get the best results. So let's finish this. Let's initially identify how many of each of these atoms present. I see 4 carbons on the left. I see only 1 carbon on the right. I see 8 hydrogens on the left, and I only see 2 hydrogens on the right. I see oxygens on 2 different places, excuse me. So I'm just going to separate them as 2 plus 2. And here I see oxygens in 2 different places as well. It's going to get a little bit messy, I can see. So let's start with carbon. So now you have 4 on one side, only 1 on another side, classic. So if you put 4 there instead of 1, 4 here, you would have 4 and 4 on both sides. So that's done. So now when you do that, did you make any changes to any other atoms? Yes, we did. We changed number of oxygens present there. Instead of having 2 like previously, we changed them into by putting 4. Now it is actually 8 plus 1. Okay. So my preference is to go to hydrogen. You have 8 hydrogens on one side, and you have only 2 hydrogens on another side. How do you balance them? Is by putting coefficient 4. When you do that, you would have 8 hydrogens here. You already have 8 hydrogens there. There you go. Now, did you make any changes to any other atom involuntarily by putting 4 in front of H2O? The answer is yes, because H2O contains an oxygen. So you need to change how many total oxygens are there, because you just put the coefficient 4. So 8 plus 4. Now you have a total of 12 hydrogens because it is the last molecule, and because we already put coefficients 4 and 4 in front of both the products, I am not going to make any changes on the product side. I already counted how many total hydrogens on the product side. So I need to come up with a way to make sure I have total 12 oxygens on the reactant side. And I already said, if you already done with balancing, you're not going to make any more changes. So I'm not making any more changes there because you're already done with carbons and hydrogen. So no more changes happening there. Only change is possible here. And I said we need total of 12 hydrogens on reactant because we have 12 hydrogens on the product side. Now, these two are not changing, right? One of the set of two is not changing. So this 2 is changing. So what we can do is we are going to multiply that 2 with 5 so that it will become 2 plus 10 by putting 5 there, so that total will be 12. That is how you would balance that. It looks a little bit tricky, but with practice, you will find the trends and you will be comfortable in practicing this. This is how I would like to do it. I think this is breakthrough in separating same elements if they were between two different molecules into two different within appearances like 2 plus 1 or 2 plus 2. That helped a lot for many students when I explained previously. So I'm using that method to explain. This is what typical textbook method is. I'm just going to pause here and show it there and see if you like it. You can follow it. I have no problem whichever method you follow. I just need you to find the right way to do it. Be it my method or be it textbook method or be it any good better method than me, anybody from internet, I have no problem. Whichever method you find, as long as it is right, I am okay with it. That's all from part 1. Maybe hopefully part 2 will go a little bit quicker than this. But whatever the time we spend on balancing chemical reaction is totally worth it because we are going to use it, not only in this chapter, in the future chapters as well.